The question we are solving now belongs to test series 7. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. As per the question, there is a magnetically coupled coil as shown in the figure. The coil 2 in the circuit has a self-inductance of L2 and the mutual inductance between these two coils is M. The primary coil carries a current of I1 and it is connected to the current source I1. The secondary coil carries a current of I2 as shown in the figure. The dot convention for the magnetically coupled coil is as shown in the figure. And it is also given that a current phasor I1 is equal to 3 times I2, and we need to find the possible values of L2 and M in Henry. For finding the possible values of L2 and M, let us apply the KVL to the secondary loop. We see that the secondary coil will have mainly two voltages drops across it, which can be written as V1 and V2. Here V1 can be written as minus j omega L2 I2. This is the drop due to the self-inductance, and V2 can be written as j omega M I1, and this is the drop due to the mutual inductance and hence due to the current through the primary coil. Here the current I1 is entering the dotted terminal of the coil, so it will produce a voltage which is sensed positive at the dotted terminal of the coil. So by KVL we can write that V1 plus V2 is equal to 0. From this, upon substitution we can write that minus j omega L2 I2 plus j omega M I1 is equal to 0. But it's already given that I1 is equal to 3 times I2. Upon substituting the same, we see that L2 multiplied by I2 is equal to 3 times M multiplied by I2. This is because of the reason that I1 is equal to 3 times I2. And from this we can say that L2 by M should be equal to 3. So the values of L2 and M will be such that L2 by M is equal to 3. Hence the correct option which represents the values of L2 and M is B.